Hello engineers, welcome to Mechanical Training World channel. Today we will discuss about example problem on nozzle with reinforcement calculations. So let's begin the session guys. This is the given data for the problem, that is material of construction of shell and material of construction of nozzle, internal design pressure and external design pressure and design temperature, inside diameter of the shell. And we need some more data to calculate the reinforcement, that is shell nominal thickness, corrosion allowances, and nozzle schedule for calculating the nozzle thickness and nozzle nominal diameter for the shell, projection inside and projection outside. Projection inside and projection outside is for nozzles, guys. So this is the given data. So let's try to calculate the required area for reinforcement, guys. So first we need to calculate required area for reinforcement. So we know that if you open the code book, you will find this formula for required area for reinforcement. So that is A equal to D into TR into F plus 2 T and TR into F into 1 minus FR1. So let's try to find out FR1 first. So we know that FR1 is equal to allowable stress per nozzle by allowable stress per vessel. So we know the material of nozzle, guys. That is SA106B. For SA106B, the allowable stress is 118 megapascals. So you will find this value in section 2, part-3, guys. So please refer that book. And for shell, SA516 grade is given in the given data. So for that one, allowable stress is equal to 138 megapascals. So this value also you will find in the section 2 code book. Substitute these values in the FR1. So if you substitute these values in the FR1, you will get FR1 as 0.855, guys. And next we try to find out F, that is correction factor. So by using this graph, I need to find the F value, right? But in given data, there is no data related to there is no data given related to this angles, guys. So we need angle theta, then only we can find F value. So for that one, I am assuming theta as a 0. So if theta is equal to 0, our F value is 1. You can see here. So we also get F value. And we need thickness of shell and thickness of nozzle to substitute in the formula. So let's calculate that values too. The very first one is required thickness for shell. So we need to calculate required thickness for shell, guys. Here you can see in the diagram. So we know that UG-27 gives the required thickness for shell, right? So I'm applying the same formula here. TR is equal to PR by SV into E minus 0.6P. Here E is the Young's modulus. So this value also available in section 2 part D. So you can take value from that. As of now, I'm considering E as 1, guys. So Young's modulus E means. So P is equal to 1 internal design pressure. R is the 1003 by SV equal to 138, E is equal to 1 minus 0.6 into internal design pressure is 1 megapascal. So if you find this value, you will get required thickness for shell as 7.3. This is without corrosion. So we are not considering the corrosion allowances, guys, because we need to do for worst case scenario. So that's why I'm not considering that 3 mm as corrosion allowances. So let's try to calculate same for the nozzle also. So nozzle thickness, we know that nozzle schedule is equal to 80. From that we get 12.7 as the nozzle thickness. But we need to remove 3 mm corrosion allowances because we need to do for worst case, right? So if you remove that 3 mm, we will get nozzle thickness as 9.7 mm. So we got required thickness for shell and required thickness for nozzle. So let's try to substitute in the formula. So this is the formula given in the code for required area for reinforcement. So if you substitute your values, you will get required area as 1480.5 mm square. So this is the required area for reinforcement. Let's try to find out what is the available area. So what is the available area in our shell or nozzle section? So let's find out for first cell side that is parallel to the vessel. So first we need to find out parallel to the vessel, then we need to find out nominal to the vessel. Okay. In UG-40 limits of enforcement, we already discussed these formulas. So if you didn't watch it till that video, please watch that video first and then watch this video. So you will get clear understanding. So let's calculate in the first case. We need to calculate for D case and we need to calculate for Rn plus Tn plus T case. So I'm calculating for first case. So this is the formula given in the code for the first case, guys. Please open the code book and refer the formula. You will get better understanding while listening this video. So if you put the all the values in this formula, you will get A1 as you will get A1 as 334.23 mm square. So let's try to calculate for second case as well. So this is the formula given in the code for the second case. If you put all the um, values in this formula, you will get A1 as 58.62 mm square. So we know that we need to consider maximum of these both values. What is the maximum value here? That is 334.23 mm square. So finally, available area A1 is equal to 334.23 mm square. So next, we need to calculate for nominal to the vessel wall. We need to calculate nominal to the vessel wall, guys. So I already explained this formula in UG-40 session. So let's try to calculate for first case, that is 2.5 into T. So that is A2 is equal to 5 into Tn minus Trn into Fr2 into T. So this Tn is the nozzle thickness, and this TRN is the extra material available, 0.85. So if you calculate all these values, so here you can observe one more value, that is FR2. What is the meaning of FR2 here? Same. So we are also calculating nozzle and shell, right? So both the materials are different. So we need to calculate FR2. So the same value will come, that is 0.855, and T is the 9 mm. If you calculate these values, you will get A2 as 340.5 mm square. So this is the first case scenario, guys, and we need to calculate for second case, that is 2.5 into Tn plus Te. Te is the effective pad thickness. Effective pad thickness, guys. So this is the formula given in the code for this second case. So if you substitute the values in that formula, you will get A2 as 13303.3 mm square. But we know that we need to take minimum of these two values. Minimum of these two values, guys. What is the minimum value? That is A2 equal to 340.5 mm square. We calculate A1, that is parallel to the vessel, and we calculated A2 value, that is nominal to the vessel, guys. And let's try to calculate area in the nozzle. What is the extra area available in the nozzle? Because this is the area extra available in our case. So we need to find out A3. This is the A3. So if you calculate A3, you will get 192 mm square. So I'm not explaining all these values, guys, because you will find all the terminology in the code book. So I already explained all about this in the UG-37 session. So please refer that video so you will get better understanding. So and next we will calculate area of the welds. So majorly three welds we have. One is nozzle to pad connection, pad to vessel connection, and vessel to nozzle connection. So we need to calculate area for these three welds. So let's try to calculate for first one. This is A41. That is leg height whole square into FR3. FR3 is nothing but the lesser of SN or SP. So we are calculating for these two, right? That is pad and nozzle. So this is and this is also connection with shell. So we need to calculate lesser of nozzle allowable or pad allowable divided by SV. So if you calculate these values, you will get A41 as the 85.5 mm square. I'm assuming this 10 as this height, guys. I'm assuming this value. This is 10. This is 10 mm. So this is the height, leg height. So I hope you are getting the point. And next one, A42 for this one. This is the A42. Assuming same thing. So A42 is equal to 10 square into 1 FR4. That is pad by SV. I'm considering here pad and vessel as the same material because I'm not getting any material for pad in the given data. So that's why I'm considering this both are same material. And next we need to calculate A43. That is this one. So same thing. So A43 is equal to 85.5 mm square because 10, and FR2 is the same one, vessel and nozzle allowable stress ratio. So we'll get 85.5 mm square as A43 and A41 as 85.5 and A42 as 100 mm square. Now let's try to calculate A5. A5 is the pad version. So we need to consider area, required area, or available area for this pad, guys. So if we calculate this A45, so you will get 1567.2 mm square. So let's try to calculate available area, total available area. Total available area is equal to A1 plus A2 plus A3 plus A41 plus A42 plus A43 plus A5. So if you substitute the values, we'll get total available area as 2704 mm square. So let's try to compare with the required area. We know that required area A is equal to 1480.5. So our available area is greater than A value. So our design is safe, guys. So if our available area is less than required area, then our design is not safe. This is how we need to calculate the required area for the reinforcement. Okay, I hope you are getting this example problem well. So in next lecture, we will discuss about UG-38, that is fluid openings in the shell and formed head, guys. Until then, keep subscribe my channel and click on the bell icon. You will get notified if I upload any new videos.